there's so many different areas to focus on and so many different types of skills. They're not all applicable for every job, and not everybody needs to learn everything. I would say yes, it is the easiest job to get into, but
What do you think is the most challenging job out of those 19? Did you end up using
uh,
math at work, like in any of your robotics projects? And how about AI? Do you need a lot of math for AI, machine learning and AI as well?
yes and no. So the question is, which challenge do you want to tackle? Do you want to tackle the challenge of being in perception and there being so many candidates that you have to be the top of the field? Sometimes getting a master's will help.
Found your video on YouTube while I was trying to come up with a roadmap for self-driving cars or humanoid robotics. And I found it very informative, actually. It was really a good video.
All right. Well, thank you so much for having me. I'm happy to be here. I have a very non-standard path towards becoming a robotics software engineer. I actually originally, like out of high school, started with a film major for the first year. I did 2 years of AP Calculus and a year of AP Statistics, so I loved math. But when somebody suggested, "Oh, maybe you should do programming," my initial reaction was, "That sounds really boring." But that was because I didn't know anything about it. And so I did a year first as a film major, and then left the school that I was at just for religious differences, and I ended up teaching English in China for half a year and came back and joined the Marine Corps and was in the Marine Corps for 5 years. And then when I was looking at getting out, I was looking more as an adult as, what's a good career path. And I found when I looked at software engineering, it seemed really interesting from a like, okay, I like solving puzzles, it's very financially stable. And so looking at it from a different perspective, I opened my mind up to it. And so that's where I started my degree on computer science. I had done a lot of credits before then until I got to that point. And so I only had about a year left to finish a degree. And so I was working on classes while I was deployed, and then I came back and I had about a year where I was a full-time intern at a small CubeSat radio company. I kept doing classes, and then once I graduated, I ended up starting at a defense company. That was an easier transition from the military, and that was more of a very large aerospace company. So it was a great experience to work on different types of projects because the company was so big. I found that I was really interested in computer vision. So after a couple of years of working there, I did, automated testing, plane-based radar algorithms, and augmented reality there. I found DECA, which is more of a robotics company, and there I got to work on multi-target tracking, board bring up, remote control, several different areas. And it was neat because then we're in earlier stages. So you kind of get to hold many different hats, like whatever they need help with, you're able to kind of jump in and help with that problem. I worked there for several years, and then I ended up going back for my master's degree in applied mathematics. I felt like I could really benefit from learning more in mathematics. I had that gap while I was in the military where I didn't use much math. And then getting back in and trying to read papers on multi-target tracking, it gets really complicated really quickly. And so using my military benefits, I went back to school for a master's, completed that, and then ended up joining Third Wave, which is autonomous forklifts. So that was another area where I got to work on robotics. It was more on the SLAM problem and working with LiDAR points. So that's the majority of my robotics experience, but I have found that I really love and have a passion for robotics now.
Very interesting background. So you have close to a decade of experience. Is that correct?
Yep, yep.
You got your bachelor's in computer science, and then you worked a few years, and then you got a master's in math. Why did you go for a major or a master's in math?
There were a few different reasons. So my first requirement was what I needed it to be like friendly with military benefits that I had. Um, but I felt like the degree in math was helpful because that was my weak point. Like I was very, very strong on the computer science side. I could build any type of architecture with different types of classes working together. I was very comfortable with multi-threading and design patterns and data structures and algorithms. But the mathematical side was what I felt like I could really use a boost to bring my robotic algorithm development to the next level. So that was what I wanted to really focus on.
Did you end up using
Uh,
math at work, like in any of your robotics projects?
yeah, I mean, SLAM is very math heavy. So I mean, it gets to where math is very useful for reading papers in the beginning, like, and then to understand the papers, then you go to existing implementations and then you start to dive into the code. And then when you bring both of them together, it helps you really apply that in an application where you can actually use it. So math is useful. You need both in robotics. So
Right, right. And how about AI? Do you need a lot of math for AI, machine learning and AI as well?
yes and no. So to actually use AI, things have gotten so easy that you can just write a couple lines of code and you're using AI. And when I say AI, I'm specifically meaning more machine learning because it gets very vague when you're outside of machine learning. What is AI? Like I've been playing around with the Ultralytics YOLO algorithms, and that's like, I don't know, 5 lines of code, and you already have it implemented if you have a data stream already written and running. Now, where math gets useful in AI and machine learning is if you want to have intuition on, okay, this is not working well, so what do I need to do to change it? I need to tweak these parameters. What's actually happening behind the scenes using mathematics to be able to produce a better result, right?
Right. Yeah, very good point. Yeah. I've seen almost a trend where a lot of people are thinking about transitioning to robotic software engineering or robotics like AI engineering or the combination of both or the intersection of robotics and AI. Actually, I came across a video on YouTube where a very experienced developer was actually like analyzing the market and talking about pros and cons and whether they should or should not consider pivoting to robotics. I want to play that video for you, maybe the first 40 seconds or so, and then get your thoughts on it.
Today, I want to talk a little bit about robotics. I've noticed a lot of news around huge investments in companies building AI powered robotics. Amazon, OpenAI, Microsoft, and a lot of others are putting a huge amount of money into this space. And I, like a lot of other software developers, are trying to sort out what that means for us and our careers and what we're going to be doing in the future. I thought today we'd cover a few questions and just kind of walk through how that might play out.
So I watched the first 40 seconds. The question is like, should other people move into the robotic space if you're a software engineer? And I would say it really depends, right? So if you're a web developer and you have no experience in robotics, you're going to have to take a lot of time to learn all of the skills that are relevant. So it may not be a great option for you. User interface might be the closest thing, or maybe remote control because you have to have a web-based platform to be able to interact with a robot potentially. But if you have an area that you're working on that has relevant skills, you may want to look at the skills that are applicable to you. If you're just really interested in robotics, you want to spend some time focusing on learning robotics-based things. Um, so game developers would really easily transition to simulation. There's plenty of people in the embedded space that would pretty easily translate, whether you're working on drivers or making things more computationally efficient. There's, yeah, so should you transition to robotics, it's really if you're interested in it and if you're willing to spend the time to learn the skills to kind of fix the gap, close the gap on the things you don't know.
I see. Yeah. The other question that I've been asked, and it was one of the questions in some of the questions we got from the LinkedIn audience was, is like humanoid robotics and self-driving cars, is it more of a hype at this point, or is it something that will take up? So people are trying to, find the answer to that question. And then when they have the answer to that question, they can decide whether they should consider like pivoting to robotics or not. What are your thoughts there? Is this thing real or just maybe a very early stage at this point? Do you think there will be
Yeah.
opportunities, really huge opportunities in the future? Do you think if people do not upgrade or up a skill, their existing skill set might, get antiquated? Or what are your thoughts there?
So starting with the humanoid, I mean, I don't think there are great use cases yet. Oftentimes, the things that are working well in business are when you have a very specific problem that you're trying to solve, and you create your robot to solve that specific problem, like to automate, or to work in a real world where you're avoiding like the dangerous situation for the human, that type of thing. Humanoids, I haven't really seen great use cases yet. And in part, they're trying to do like everything, right? So you need to have that very specific problem of what you're trying to solve. There's also the negative stigma, as was mentioned in the video, of like if you have iRobot and you have humanoid robotics, like there's a little bit of distrust with robots. So trying to get robots to work and do everything in areas where they're less supervised is tricky. Yes, you do need to up your skills always. You're in the tech sector, so things change like every couple of years. When working with YOLO, I had finished an implementation with YOLO 8, and the day I finished, YOLO 9 came out. So it's like you got to work on, learning every single thing. Well, that's like applicable for your job area, to stay relevant. But oftentimes people like us, we love technology. So what we do for fun is technology. We bring up like different projects that we want to do for fun, or we listen to podcasts like this, But that helps keep us relevant and stick with what's improving, I guess, and upgrading in the tech sector. It's definitely hurt me sometimes being a generalist, because sometimes you go into an interview and they're looking for something very specific. And if you're not deep enough in one certain area, then they're like, maybe you're not quite the right fit, right? So being a generalist opens it up to where if you're very comfortable in a lot of different areas, you don't close doors. But so there's benefits in both. Uh, it's kind of hard. I would say initially, don't try to tackle everything. Try to pick like one focus area so you can get in the door, you can have a solid interview, talking about your experience and skills in a certain area. And then if you find that you're more interested in something else, or there's opportunity within your company or somewhere else that has somewhat similar skills, then maybe try to branch yourself out from there. But that's part of why I made this video, was just there's so many different areas to focus on and so many different types of skills. They're not all applicable for every job, and not everybody needs to learn everything. So it's better to just kind of focus on one area initially, and then once you have reason to expand out, then do that. Yeah, so I am going to my YouTube channel, to be honest, because to make this video, I really just like thought up logically based on my experience, how could I break it down to make it easier for someone getting into it and doesn't know what all of the different options are, and make it a little bit easier to find like one path, right? And so this
Right.
is really just based off of my experience. I didn't pull it from anywhere else. But the different jobs, localization, which is just finding, where is the robot, mapping. I kept those separate, even though you can do SLAM as a full algorithm, because you can, you can have creating the map as like one team, and then making sure the localization works, leveraging the map as a separate team. Um, it depends on what company you're at. Sometimes they'll have them merged and sometimes they'll have them separate, but I wanted to put them out there as different options. There's also, if you're on a drone or something, you may be running online and you may not be collecting a map previously. So that'll be on the same team. But those are two different like components that you could choose to get into. Mapping is just collecting all of the data, creating maps that's going to be storing it, and then figuring out a way to have some type of organized managing system and then loading it on. And oftentimes you'll have to like separate the maps into submaps. So just figuring out algorithms there. DevOps is definitely one of those things that when it runs well, it makes everything else run smoother. When it doesn't run well, it will put blockers on your way. So that's, having things loading up in the cloud, and having processes run, maybe like after robot runs, you can see all of your plots and systems that you've set up to be able to produce results. It just like helps the full system, run better. Human computer interfacing. There are some interesting questions like different naming of this, which I think there are definitely different names of this, but I really wanted to just convey how the world interacts with your robots. Sometimes the world will interact just by visualizing. So like an autonomous system, can they tell like, are you turning right? Are you turning left? Are you going to go at a stop sign? Because that can be very iffy. where sometimes a person will just indicate, you know, but what does an autonomous vehicle do? And sometimes with other robotics, like surgical robotics, it gets a lot more intense. I would imagine you know better than I do on this one, but how does a surgeon interact with the robot? Does it do what the surgeon would expect it to do? So that's a lot more like very specific, you know, does the user know how to interact with the robot? So there's kind of two sides of that. Controls is going to get down to how does the robot move and can you control it properly to optimally move so that the path planners can then write a path that'll allow it to move the way you need it to. And that can get interesting because if you're in different types of environments, it might change and it might be dynamic. If it's raining, if it's snowing, if you're going on rubble versus just a paved ground. Drivers, drivers is dealing with like interaction with sensors. So you're writing, you know, handling intake of information from those sensors. And that gets like very low level. So electrical engineers might go towards that direction, working with drivers. New device bring up is, you know, there's a couple different stages where you have to write the scripts to be able to, you know, load the image onto the board. And figure out all the what IDs do you not need to put on the board. So there's the creating the process of new device bring up, but then there's also the actually having the person carrying out the procedures of just bringing up each new device and testing and making sure there's like an initial validation of, okay, this bot works, so we can hand it off and have it either be tested further or be sold or whatever the process is, be used for development. Path planning is going to be, you know, for anything that's autonomous, it's going to be figuring out how to get from point A to point B. For a robotic arm, it'll be more of how do you move the joints properly so that the manipulators can get to where they need to be. Manipulation gets to where, you know, the manipulators like the robotic arm can pick something up. And depending on what you're picking up, there might be like a lot of fine grained motor skills, you know, to make sure that it's not going to break an egg while it picks it up or break packaging or break whatever it is that it's trying to handle, right? So that can get really interesting. Remote control is going to get more into networking, so interacting with your robot so that you have a component on the robot that handles taking in messages that can control it, and then having a user interface component, and they connect over networking, which might be over Wi-Fi or it might be over a data phone plan or some type of system that's outside of Wi-Fi, and that gets even more complicated because you want to make sure that you just don't lose signal in the middle. Perception, this is like the hot field nowadays. Everyone's getting into machine learning, object detection, segmentation. It's a lot of like recognizing what's in your scene. I think a lot of people are honing into cameras because that's where a lot of the work has been done, and that's one of the cheaper sensors. But I think there's a lot of desire for people to have more experience in other sensors like radars and lidars and, you know, ultrasonics, different types of sensors. I actually have another YouTube video which goes over 5 different types of perception sensors. So tracking, like multi-target tracking, is what are the things around you that are moving and how do you avoid them, and take that in consideration with your path planning. Calibration is you have each of your different sensors and you need to make sure that the robot understands where they are in relation to each other. If you think your sensor is a little bit off, then everything else that uses that sensor information is also going to be off. The executor is a system that kind of manages all of your different pieces of software that are running at the same time. And it needs to kind of classify what are the critical systems and what do I do in the scenario that a critical system goes down? How do I handle something crashing? You know, so it might also store certain required log information. If an autonomous vehicle crashes, like what does the executor do if something goes down? What do you collect? What do you store? So the user interface is just the user interacting with the robot, telling it like what it wants it to do or telling it to stop or continue going, whatever. Simulation is going to be creating a simulation environment where you can test the algorithms that are being written for the robot. I loved having simulation as like a first pass test. Okay, everything seems to run in the happy environment where sensors are perfect. Now I can take it out, and be able to run it in the real world and see how that interacts. But that's a good first pass. It can get really complicated from a developer standpoint because you're doing all of the graphical pieces, and oftentimes it happens at certain hertz rates. So it gets really computationally expensive. You need GPUs on your computer. Having worked with Unity before for augmented reality, I was really familiar with what development the simulation team was doing when they were helping us. So that was nice to be able to interact in that way. But it can also be helpful to be familiar with like 3D modeling if you do simulation. Data analyst. So I will say everyone on the core team is probably somewhat of a data analyst because you end up with tons of logs based on all of your tests and you have to make sense of them somehow. Putting them in the correct plots that make it interpretable to you so that you can quickly discern what happened in the testing and then be able to have reactions to that to better improve your code is crucial. But if there are people that are really good on the data analyst side and you're at a bigger company, you may have people that are more specifically the data analysts that can work with people that are on the core algorithms that can help set up the plots so that DevOps and analytics can happen more seamlessly. Optimization. Well, there are a few people that are like focused on optimization. I feel like these roles are probably going to be at larger companies that can afford having someone specifically looking at optimization. I feel like every company needs somebody that focuses on optimization because you always hit a point where you're limited on what you can actually put on your boards. You're running out of CPU or GPU, and so whether it's you need to convert your Python code to C++ code, or you need to look at your algorithms and kind of parse out what's taking up all of the compute, whether you need to fix your data structures, maybe like putting in LiDAR point clouds more into tree structures so that you can be more efficient. There's a lot of things that you can do to better optimize. And if someone's really good at that, like you are gold at a company. Testers, we've talked a bit about this already, but there's the whole range of people that just come in and that can handle like these are the procedures you need to carry out and perform for testing, or there's unit testers that can write unit test code for your algorithms. Sometimes you're the ones writing your own unit test code for your algorithms. There's also testers that help with creating more like mechanical setups but maybe get like base level software on there for running with the testing situation. There's like testing can span a whole number of things to be able to get each of the different types of robots working, but it's really important. And then the last couple that I mentioned that weren't part of the 19, but were kind of bonus roles were one, customer troubleshooting. It can be really important to be able to work with a customer, understand their problems, and try to understand like what are possible solutions to their problems. Sometimes it's really simple errors of just not understanding what's going on, and sometimes they found a bug where there's code that needs to be fixed and changed. So trying to interpret what is the issue and bringing it back so that the developers can understand it. That does take technical skill, but also human interaction skill. We also have the customer integration and sales. So that's trying to understand limitations of the robot and understand the needs of the customer and trying to merge those two together. So it's important from a technical standpoint not to promise the world so that your customers don't get dissatisfied when your robot is, I won't say human, but is like realistic. But it's also important to like highlight the things that your robot does that's better than the competition, or how much value your robot can actually bring to the customer and why they should want to pay for it, right? And then I get down to the managers. So there's a personnel manager and a technical manager. Sometimes these will also be the same people that are your developers with you. Sometimes there will be people that'll be like separated out as technical managers or personnel managers. The personnel manager really focuses on the people. and making sure that their goals align with the company's goals for them so that they don't get completely dissatisfied at something and leave, because having people leave from your company can, put halts and disruptions into the code development. So it's good to understand people and understand the company to make sure the goals align. Technical managers are going to be focused on the projects and the deadlines and making sure you have the right people solving the right tasks. And if somebody has ambitious goals and they think they're going to do this, having them put them in check and be like, okay, maybe this doesn't work. Maybe this isn't the right solution. What about this? Kind of having those high level views of how the whole system is working and making sure everyone's moving in the right direction and kind of giving focuses for people when they need it. So
All right, perfect.
there we go. That's everything.
Yeah, 19 different jobs. That was a very comprehensive list. I would like to add maybe two more to it. Like
Okay.
there's a role that we have, and then I've seen some self-driving car companies, autonomous vehicles companies have, that's called systems engineering. That's another role. And then also you touched off one of them, which is another one, which is usually called technical program or project manager, similar to what you described. So yeah, so very comprehensive list, and thank you for that. I'm gonna start with someone who is thinking or planning to transition into robotic software engineering. So what area do you think is easier to get into? Is it like autonomous vehicles? Is it surgical robotics? Is it humanoid robotics, or is it something else?
I mean, I would say autonomous vehicles is easier to get into than surgical robotics just because the number of companies that have autonomous systems is going to be a lot greater than the number of companies that are doing surgical robotics. Just from looking into potentially entrepreneurship with medical devices, like it takes a lot to get into medical devices. And when you talk about surgeries, that's a very critical system that, you have to have like all your ducks in a row, everything working precisely from the business side to the engineering side. And so that's just gonna narrow the field insanely. Now, you could do just as much damage with autonomous vehicles, out on the road and the freeway. There's a lot less regulation so far, which I think is just a matter of like regulation not catching up yet. But so I would guess that it's easier to get into autonomous vehicles. If you're trying to look into like a certain field to get into if you have less experience, testing is a great area because there's a lot of jobs in robotics type fields that require someone to just go out and follow certain procedures and steps during testing. And you don't need like the software development skills to be able to do that, but that gets you in the door so that you can talk to people that are doing the software development and you can see what are the skills that you need for this specific job. Because if you're already in the door at a company, then that's an easier way to transition. Mapping is another area that and I'm not saying writing the code for mapping, but basically going out, taking your robot and collecting the map. You'll often have to like walk the robot around a certain area so that it can collect all the LiDAR points or camera points, whatever you're using for creating your map. And that's just a procedural thing. Also, board bring up, if you're more mechanically savvy, you may be somebody that wants to work on like bringing up each of the robots and flashing the initial software on the code. That's a little bit more, requires a little bit more skill, but it doesn't require as much of the, just understanding the full software development cycle. So those are a few of the jobs that are a little bit easier to get into, and you can build up on your skills to be able to transition to something else if you're interested in it down the road. Yeah, so that's whether you should go from a different non-robotic software engineering company to a robotic software engineering company as a tester. I think testing likely will be able to transition somewhat easily, but some of the differences with testing and robotics is you're actually going out with a physical thing that's moving, right? So oftentimes there are very procedural elements that focus on safety or focus on achieving certain goals. So when I did multi-target tracking, I came up with this testing procedure that focused on the areas that I felt like we might perform worse at. to make sure that we would have our software, up to snuff to make sure that we performed at least as well as we needed to in those challenging scenarios. So the tester would take that, they would run the robot through these different types of scenarios and bring the results back to us. And so that would be part of the role of a robotics tester. I'm trying to imagine a non-robotics tester, what their roles are going to be doing. I would imagine it's more like getting in a user interface, clicking through things, trying to see if they can break the system. So if they could somehow translate that skills of them understanding how a system is meant to be used and trying to think of it from a different user perspective and how it might be used and what other people might do from an outside perspective, and then showing how they would bring results back in a very clear, informative way, then I could see how those skills could definitely translate. And that is really crucial. If you can bring information back in a clear, informative way, timestamps, what was the weather like? What was the scenario? Was anyone standing in a weird situation that might have affected something? Like all of those pieces of information are really useful for us, but somebody that may not be, in the software development, like core development, they might not think about it because they're not necessarily understanding the full system. Should someone transition from testing to any of the other algorithms, I think if you're wanting to get into one of the core software development roles, testing is a great way if you don't yet have those base skills. So I think that's a really good plan. If maybe you just know Python, you don't know enough of the C++, you can write quick text test scripts that can be supportive, and you can work on learning your C++ along the way while you try to get into a more core development role. If you're more of a senior tester, the question is like, you've been testing for a long time. It seems like you're well into your career. So why is it you're wanting to make the transition? So it's just a question of if you want to put the time in towards learning new and different skills, which gets less advantageous the further you are in your career. So
Yeah, that's a
personal
good point
choice.
too. Can we say testing is perhaps the easiest one to get into? Or my question is, out of those 19 different jobs that you talked about in your video, which one is the easier to get to for someone who is trying to get
Yeah,
into robotics?
I would say yes, it is the easiest job to get into, but that being said, there are many levels of testing. So there's absolutely advanced testers that do crazy, insane things that, the junior tester is not going to be able to do and is not going to have an easy time getting into. Like we were requesting different test rigs that made it possible to run some of our testing situations and scenarios that required very advanced like mechanical and electrical skills to put these rigs together. So don't undermine testing. Testing is very important and it takes a lot of skill to do it at the senior level, but it is probably one of the easier jobs to be able to get into at the junior level if it's more just procedural supportive roles.
I see. Yeah, good point there. What do you think is the most challenging job out of those 19 different jobs that you listed?
Yeah. So my first inclination is to say path planning. I'm saying that with a grain of salt because I haven't done path planning, but I'm saying this based on my experience working on the SLAM algorithm. And when I worked on the SLAM algorithm, something that would come up frequently is, okay, this isn't working. Why is it working? And you're relying on a lot of different other areas. Calibration needs to be correct. So it's possible the calibration could be wrong, right? The sensor flow and, the CPU handling of all of the different systems across the board needs to be correct. Now, looking at that, taking it to path planning relies on even more things, right? So you rely on making sure perception's working correctly because you have the multi-target tracking. And if that's accurate, you're able to avoid it. So if you're making a path planning algorithm and you're relying on localization needs to be correct to say you're in the right place, your tracking needs to be correct, to make sure you're avoiding things that are moving. Your calibration needs to be correct. The question is, at the end of the day, if it's not working correctly, which component is not working correctly and why? So trying to debug and parse out, each of those different pieces and understanding which component isn't working seems like a really big challenge.
I see. And then from a skill set perspective, is it also the most challenging job? Like the number of skills you need, or like do you need advanced math and computer science skills?
Yeah, I mean, From a skill set perspective, I feel like a lot of the core jobs are going to be equally difficult, to be honest. Like from SLAM to path planning to multi-target tracking. For each of them, you need to be able to write the code and make it all work together in a system. But then you also need to understand how to read the papers of like the most recent developments and implement those papers, and then be able to write the full cycle of, capture your logging and interpret the logging and then create the plots and understand what's actually happening, and then make sure you have testing that's properly set up so that you can see what's actually happening in the real world. So it's, I would say they're all hard, but they have
Right.
similar types of skill sets. I guess from the difference between like path planning and multi-target tracking or SLAM is you're working with the sensors for multi-target tracking and SLAM. With path planning, you're caring more about like the physics, and the mechanical components of like how the robot moves. So differences
Right.
there, whichever you find harder.
Sure. Yeah. Which of these job families uh, have the most potential, like most growth potential?
The most growth potential. I think my first thought of a reaction to this would be SLAM. Um, and I say this because there's a lot of skills that are necessary in SLAM that would translate to a lot of different other areas if you needed to transition, but it's really hard to get into SLAM. In part, it's just really complicated. There are a lot of different components of the algorithm, a lot of different options that you can choose to go into the algorithm, and there's not as many resources as most people would want to be able to learn to get into it. So, I mean, you have probabilistic robotics, which is a great like base level. You have Cyril Stackness. I always butcher his name, but his videos are amazing on YouTube. He has great, SLAM educational videos. But from learning how to do like software development, like bringing the whole system together, learning the mathematics and intuition of how all of each of the sensors come together, doing sensor fusion, learning Kalman filters, particle filters. Some solutions will involve some machine learning, but it just there's a lot of different areas that you can learn and you can potentially leverage in different areas.
And then also in your video, you also say or mention that Islam is in high demand. So yeah, that would be maybe a good job family for someone to get into and learn all the skill set that is required, at least to have a
Right.
competitive edge, right?
If you look at robots, like when you start to build and create a robot, the very first thing that you need is for it to be able to move, right? So you do the controls initially, and then right on top of that, you need SLAM so it knows where it is so it can move. So that's one of the first things that you do. I guess controls and drivers so that you have your sensors coming in, calibration, and then SLAM. So the SLAM is like the first, type of core algorithm that you're going to be writing once you have the full system up and running. Um, and so that's where it's needed more. You can't get to tracking and you can't get to path planning unless you have SLAM working well, right? So
Right. So if you have a mobile robot, whether it's an autonomous vehicle or humanoid or vacuum robot or anything else, even AR, VR, right? So SLAM is used, and that's probably why it's in high demand because it's used a lot in different robotics projects. Is that
right,
correct?
absolutely. Yeah. So in AR, VR, it gets interesting. I mean, I worked with the HoloLens, so a lot of that was actually done within the library of the HoloLens that was available for users. But if you're working like on a mobile platform, you definitely need to recognize what is involved in the world around you, like use the phone, whatever sensor you have on your platform, so that if you place a marker or you place something in augmented reality, it'll actually stay in the world wherever it is you're trying to place it as you move around, right? If you want it
Right.
to be like on the surface of a desk, you need it to stay there. So you need to recognize where is the desk as you move. So that's, yeah, SLAM is important for that, definitely.
All right. So you mentioned AI and machine learning engineers. So if someone is a machine learning engineer but is working for a fintech or other companies and they want to get into robotics and maybe work in the intersection of robotics and AI and machine learning, uh, what of those job families would you recommend for that specific person?
The first easy one is to say is perception, because there's a lot of different tasks that handle recognizing your area and being able to leverage that, so that you can interact with the world, whether it's tracking things or whether it's, using a robotic arm to be able to manipulate something, using the perception to recognize what's there, is the first task towards doing that. And something that a lot of times when people come outside with machine learning skills, it'll often be they're very skilled in Python, they're very skilled at like the process of training machine learning models. Um, but that's not the only thing involved, right? So you need to actually integrate the model once it's actually trained and evaluate how it's working on the robot. One of the limiting factors might be how good are you at C++ and actually being able to leverage that model. And that might be different jobs, but if you're wanting to do something like reinforcement learning with teaching a robot how to move, you're going to need a bit of a different skill set, right? So, it's very useful and there's probably less people in it. So it might be easier to get into if you're familiar with that than perception, just because there's a lot of people in it. Like I've seen job postings where like 48 minutes in, there's already like 48 people applying, which is insane. Um, but yeah, perception is the first area, and then you can look into other areas like tracking or like using reinforcement learning for getting a robot to move.
You mentioned Python and C++. So if someone is a perception engineer or wants to work in the intersection of robotics and AI machine learning, can you explain a little more about when in the project you would use Python and when you would try to maybe convert your Python code into C++? If you are a perception engineer or if you're a machine learning engineer?
Yeah, so generally you would use Python for the data compilation, the training, the actual creation of whatever your machine learning model is. And then you would export the model, a PT if it's a PyTorch or Onyx if you want, anything to be able to use it for the more generalized format. And then you would use that model within the C++, right? So then you would leverage that in C++ using the model that you've previously trained in Python.
I see. Okay, so basically creating the model, training the model, and creating it would be in Python. And then, but when it comes to production level code or deployment code, it has to be converted into C++, right? Maybe create the
Right.
binaries and import the binaries into C++ and use it in C++.
Mhm.
All right.
Yep.
The other question is, if someone has background in electronics and they love, building the stuff and breaking the stuff, which of these job families would you recommend?
Yeah, my first inclination is the testing, like the really complex, create some type of test rig where you can solve a certain problem, right? Because I could see you getting involved with, you have some odd requests that the developers are coming up with. They need something built, and you get to do like odd different things each time. And that takes someone that's really good at breaking and building and putting things together and making something work quickly. The other possible option could be more of like the human computer interface, because there may be a lot of like, let's try this and see how this works when people interact with it, putting LEDs on in a certain way, putting like video screens and displaying different things. So it may be a lot of like bringing things down, putting things back up, and trying different variations to get different reactions.
A lot of people who probably will watch this podcast or this, interview are people who are thinking about maybe, transitioning to the robotic software engineering. And I'm gonna lay out 3 different cases. I wanna get your thoughts on what would be a good approach or the best approach to transition to robotic software engineering. So starting with case one, say PhD in mechanical engineering with 3 years of experience, and then they know, for example, they're expert in finite element analysis, and they know the basics of Python, good at math, and they want to switch to robotics, and they have 6 months or so. What are your thoughts there? How would you go about it?
To be honest, I had to look up finite element analysis, which is really interesting. It seemed like it's a field where you're getting feedback on the situation of a robot, and it looks more into the controls is where it seemed like it aligned. Like, so based on the incoming stream of information, you're able to kind of predict what is going to happen next and what is the state. So that was where I initially went. If you're very comfortable on the mechanical side, looking at working with the software with controls would seem like it would align well because you would have a very high mechanical understanding of how things worked. And you would be able to have a little bit of that executor type like understanding of the situation. So you could feed the executor information on how the controls were doing so that it could have sort of an alert if things were going badly or if there were things that you didn't want to happen. I would say if you're going to go on the controls, you need to learn C++. So 6 months, you can definitely learn C++, get some projects under your belt, focus on that, and maybe try working with a few different control type systems to see how would you try to control it.
I also think that's a good approach. If someone has a PhD in hardware, like electrical or mechanical, control would be a good basically job to target. You mentioned ROS, but I did not see ROS or ROS developer as one of those 19 job families. Why did not include ROS developer or development? And is ROS really used in robotics and like in robotics industry, or is it more of an academic tool?
Yeah, so this is a really controversial question, I feel like, because I've heard it a lot. It is used in some robotics companies. I feel like, I mean, what ROS gives you, it gives you like a messaging system, it gives you visualizations, it gives you transforms. So it gives you a system to be able to bring up nodes, be able to communicate between each other and log things and visualize things. So it kind of creates that infrastructure for you to be able to get up and running quickly. There have definitely been limitations that companies have found further along in their development that I think have led to transitioning to other types of tools and libraries, which is why certain companies that are in industry don't necessarily use ROS. But some companies do use ROS, some companies don't use ROS, and it's just a company preference. That being said, even the companies that don't use ROS, I think they still have ROS as a like nice to have skill on, if you were to apply to that company, because then they know that you're familiar with like publish subscribe type of architecture with messaging. They know you're familiar with using transforms. They know you're familiar with the things that they're using in their company, whether it's ROS or not. So ROS developer is a very ambiguous type of, if you were to put that as one of the types, like that's not what your purpose is. Like you're developing for one of the purposes of like path planning or perception or tracking, like each of those use ROS if you're using ROS at the company, because they're sending messages, they're using the transforms, they're logging data. But ROS developer in itself doesn't tell you what your actual goal is, which is where I kind of parsed out each of the 19 different types of robotic software engineers. Each one has a particular goal of what they're trying to accomplish with the robot.
I see. So you would not consider that a separate job family, but ROS is something that there's a chance that you might use it for other different roles, right?
Right, right. It's used a lot if the company you're at uses it. Yep.
Okay, so going back to the main question, the third scenario, the third case would be I'm an undergrad or graduate student in computer science or computer engineering. I still have maybe 1 or 2 years to graduate, but I want to get into robotics, specifically robotics software engineering. Your thoughts on that one, on that case?
I would say pick the area that interests you most, because as people that are technical, you often have an area that you're like, ooh, this seems super interesting, and definitely start, putting in the effort to put in projects. The more you work on projects, the more you get skills in the areas that you're interested in. So if you're interested in working in the robotic software engineering space, there's not necessarily like one specific area you should focus in. If I told everyone to focus on the same thing, then you wouldn't have enough people to cover all of the different parts that you need for robots, right? So find the area that interests you most. Try to do a few different projects that align with the skills that would go towards there, and to try to figure out what those skills are. Sometimes what can be useful is look at companies that focus on robotics, try to find a job that in the next, year or two, like it sounded like a year or two was the goal for the timeline to be ready, that you would say, this is the ideal job that I want to do, right? And maybe come up with 5 of those and highlight these are the skills that I would need to be able to get this job that I don't currently have now. Then try to create a project that involves using as many of those skills as possible within each of those projects. And that's how you build yourself up to be ready to be able to then apply in a year or two for that type of jobs, because hopefully you've been able to, work on your projects, gain your skills, and then now you have them on your resume to be able to apply to that job.
Great answer. Thank you for that. Let's go through some of the questions that our LinkedIn community submitted. So the first question is, what do hiring managers look for in robotics projects for assessing a candidate's robotics aptitude?
I think one thing that really highlights candidates is if they've experienced some type of challenge or problem, they've really dived in to understand what the problem was, and then they've come up with potentially different solutions that might be able to fix that problem. So going through that experience of going through challenges, coming up with solutions, fixing it, evaluating, really elevates a candidate to show what they're capable of if they were to be put in the mix of a new problem and how they might handle that. So I think the worst stereotype is, somebody that's just implemented a few lines of a code of library and they don't know what's actually happening behind the scenes. So it also, if you can like explain that, what's actually happening behind the scenes, that gives you an advantage to be able to understand if something goes wrong, how do you improve, how do you deviate to be able to get the best solution for your situation that you're in, that you're trying to solve.
I see. All right, great. And I guess we went already over this question, but if you have any additional thoughts, the question is, any specific on how mechanical and control engineers develop robotics control software skills?
I mean, I don't come from a mechanical background, and having been at different companies where some companies are like, your software, don't touch the mechanics. I would imagine to some degree it's similar to how people working in computer science would also develop the skills where you start working on a programming language, try to build as many projects as you can on that programming language, and try to focus on the tasks that you're trying to solve. Try to notice what your weak points are and focus on developing those skills in your weak points. And try to focus on, what is the type of job that you're trying to do? What are the skills that they want? What are the skills you lack? And try to fill that void with both learning those skills and with creating projects that use those skills.
I see. Yeah, very good answer. Along the same line, someone asked how freshers can get jobs or internship. What are the skills required for each type of software engineer? And then also they asked, is Rust relevant in the robotics industry?
Yeah, so I think I touched on the ROS bit. It's great to use like for creating a project in robotics for an individual because it gives you that quick infrastructure for you to be able to get up and running, especially if you have hardware and you want to be able to send messages between different things. How freshers can get jobs or internships. I mean, I looked at a few internships that were out on the market right now, which was interesting because they were very different. Like you had Amazon, which is the huge company that has, the very generic robotic software engineer intern, and they're kind of opening the skills up to anything within any of those core types of robotic software engineering skills because they can place them anywhere. They're big enough that they can place them anywhere. Um, they also have internship jobs that are like specific in, I think it was user computer interface. Um, they called it a UX intern, and that's going to be more on the user computer interface side. They're going to be helping more with like the web face interaction with a robot. So that's going to be a very different skill set, right? So
Right.
I'll just name a couple of the other internships that I saw. Viabot in California was looking for like Linux, Python, C++, ROS, and being comfortable with hardware. Altitude AI was looking for more like hardware, SolidWorks, 3D modeling. So that would be good for somebody that's more on the mechanical savvy side. Trust and Robotics focuses more on like research and education. They're looking for someone to work in like driver libraries, localization and sensor fusion, navigation, simulation, ROS2, C++, Python, Git, sensor data experience. And some things that I did notice were like the ability to learn on the job yourself. So if you can prove that you're somebody that like doesn't need to be coddled at early stages, that will help out in them wanting to hire you. Like they'll accept that you're at your early stages, you want to get a job, you have some experience, but you don't know everything, but you can be able to look things up as you need to be able to learn for yourself. Um, Obviously, you'll have people to ask questions, but they don't want you to ask so many questions that you're going to stop more experienced people from being able to continue to develop. A couple other interesting ones. GE Healthcare had a machine learning engineer internship in Idaho. So something to note is if you can't find an internship like in robotics, you can look into parallel fields. So machine learning internship that was looking more into like medical recognition fields, which has parallels in robotics. So, and so I would say to be able to get a job, one, everyone is looking at LinkedIn and Indeed. Those are like the places where people highlight their jobs, right? So if that's being said and you're not getting traction because there's too many people applying, I would say start looking at what are all the robotics companies out there? Who do you find interesting? And look on their website because they may just not be advertising their jobs well enough. And if they're not advertising their jobs well enough, they're going to have fewer applicants. And so you'll have a better leg up. Also, look at places that you're interested in living because a lot of people want people on site. And if you're already local, they often will like that and they'll like that you can, be there, meet with them during interviews. Um, and then as far as just getting a job, prove that you can explain through, each of the algorithms that you're talking about on your resume, show that you're very savvy in the skills that you're working with. Well enough and you have an eagerness and passion to learn and work in their company. Like always go to a company during an internship or interview or job interview, knowing who the company is, what their challenges might be, and come with questions that like show that you've put in the effort to look into their company and you might want to know what the problems are that they're trying to solve so you can know how you can help them.
Yeah, first of all, thank you for looking into some of those internship positions to answer that question. So thanks for that. And then secondly, you mentioned self-learning, and I found that a very crucial skill. As we all know, robotics is very complex, it's interdisciplinary, and then being able to, pick up a new skill in a matter of like weeks is a very critical skill. And that's something that I usually when I interview people for internship positions, I usually look for that skill to find out if that person is a self-learner or not. So very good point there. Okay, so the other question is, beyond mastering C++ fundamentals, algorithms, and design principles, what additional steps can one take to stay ahead?
So for one, I would definitely say like keep track of what other people are doing in the industry, reading up on papers. So I track a few different things. People like you to join their newsletters, people like to continue to send out information, and some of them can be useful to be able to just follow what other people are following. So for instance, I like The Batch at deeplearning.com, Jason at ML Mastery, RSIP Vision, on LinkedIn, Towards AI, Landing AI, and Dare.ai, DAIR.ai. They give like top ML papers of the week. They've been very like LLM focused recently, but I think everyone's just hyped over LLMs. From a robotics standpoint, I found podcasts are more interesting, like RoboHub and Over the Air and the Robot Report. So those are some of the things you can like kind of look at to see what are other people talking about, what have they experienced, but then it's tricky sometimes to keep up with what everyone's doing because everything comes out and updates so quickly. Uh, you just gotta sometimes like this is probably odd, but I periodically will just like look at jobs and see what seems interesting and what are the skills that people want. And if I were to go get another job, even if I'm not even searching, like what are the skills that people are looking for and what do I lack? And so I like to try to keep up with this race of, okay, I see that a lot of people are wanting Docker or a lot of people are wanting sensor fusion, or it seems like there's a new trend towards people wanting more like vision-based SLAM rather than just using LiDAR points. So trying to create projects that involve those types of skills can be really useful. I know it's challenging because like work-life balance, a lot of times companies will want you to work like 60+ hours a week, and then you're like no time for family. So where do you fit in the projects? But I think if you're working that kind of hour, you should definitely like try to fit in a little bit of time each day for yourself to try to read up on things that you feel like you could work on improving on yourself. Otherwise, you're going to have 20 years go by and you'll be like, okay, I'm stuck, I'm behind. Little bits over time add up a lot. And so if you put in the time each day, you're going to be with yourself and you're going to be happier for it, even if, it brings your deadline just like a little bit behind. Like you're already putting well over 40 hours a week, so you can take a little bit of time for yourself.
Yeah, very good advice. First of all, I do that as well. And I recommend it to a lot of people who reach out to me. Just go and find some job descriptions. And in the job descriptions, find out what the skills they require, right? That's probably one of the best ways to understand what the skill set that specific job requires. And then you can, if you have time, you can go ahead and pick up those skills. And then secondly, just, being up to date and upskill is also very critical and important, especially in robotics. In the age of machine learning and AI, things are moving really rapidly and fast, and it's important to be up to date and know about the latest technologies or the latest methods people are using. All right, so good. And
I would also say conferences. That was the one thing I forgot to mention. Just because there's like conferences yearly where they like to highlight like what are the advances. If you're in a certain field, you should keep track of like what's being highlighted, what are the papers that are being advertised at the conferences, focused on your area of research. So that should help also.
right, that's also important. Okay, so the next question is also regarding SLAM. Someone asked, what is the future of SLAM in the robotics industry? Do SLAM engineers need to learn other generic skills like motion planning, control, and then he went on to say LLMs to survive in the market, or can they just focus on highly specializing in their discipline?
I don't see how LLMs have anything to do with SLAM, since that's like interpreting, language models. But I would say like the future of SLAM, there's a lot of visual-based SLAM, where you're bringing multiple different sensors in. Historically, it's been a lot of LiDAR points, but if you can also add in camera, one of the challenges of SLAM is if you have featureless areas, right? If you're going down a hallway and there's no features, well, if you add in a camera, maybe there's scuffs on the hallways, maybe there's certain colors that might give you more information. Then having more rich features from multiple different sensors can give you better SLAM overall. Factor graphs are definitely an area of interest and research. So I would look into that for future of SLAM. Whether you need to be skilled at like other different areas, I mean, it's really hard to predict the market. I would say SLAM is a pretty solid area to be in if you're good at SLAM. SLAM is a critical system. It's used on a lot of different types of robots, so I would imagine it's a solid area to be in, but things may change with the company that you're at, and you may want to be able to stay at that company and transition to a different field that they're working on. So that could be one situation where you might want to gain separate skills. And then just transitioning to another company, you never know how many companies actually have job postings for the area that you're interested in. And I'm sure that changes, monthly. I'm actually interested in doing a future YouTube video on more of a job analysis, because I get that question a lot of like, what's the best field to go into, or what's the easiest field? And I'm like, I don't know off the top of my head, but if I were to like parse all the data and put into some like analytical form and then create plots, I could give you a much better answer and maybe do that quarterly. So future plans there. Feel free to subscribe to my channel if you want to see that in future.
Yeah, absolutely. Along the same line, someone asked how to decide which specialization to choose, and they say, "I'm interested in perception, but so are a ton of people. I'm also learning about manipulation, but every job in this field requires PLC. I want to do controls, but people move on to RL or ML based approaches." So any thoughts there?
I mean, yes, robotics is hard. So it's definitely not going to be easy. There's going to be a challenge in every area you look on. So the question is, which challenge do you want to tackle? Do you want to tackle the challenge of being in perception and there being so many candidates that you have to be the top of the field? That would be the challenge there. So you have to like really hone in and be the best. If you feel like you can be the best and that's what you're interested in, great, do it. If you're wanting to go more the controls, and look into like reinforcement learning and machine learning based approaches, I think that's a great tactic to look into and, play around with and try to create projects and see how well you work. It's just a question of like which area are you most interested in, so it's hard for me to answer that question when I don't know like what are your skills, what are you interested in, what do you want to spend the time focusing on. Don't focus on everything, because if you focus on everything then you won't be good enough at one area and you'll just fail in everything. Try to focus on one, maybe two, if you want to have a little bit of breath, but I would say start focusing on one, get really good at one, and then from there branch out. But yeah, don't stretch yourself too thin. Just try something, go with that, see if you can get enough traction. That's all I got.
Great answer. Thank you for that. And the last question from our LinkedIn and YouTube community is it necessary getting a master's in robotics to transition to a robotics role or work at a robotics company?
Is it necessary? No, I didn't have my master's before I was starting to work on multi-target tracking at the first robotics company I worked on. You can definitely get in without a master's. It does make it easier to get in if you have a master's. I felt that like as a vulnerability, if I were to move somewhere else, that I'm like, yeah, I see all these job postings and everyone wants a master's. So the question is, do you have the job experience to be able to prove that you've done something to be able to get into that type of role, or project experience? If you haven't worked in robotics before, but you have project-based experience and you can explain what you've done really well, you can show you're very intelligent, you're quick to learn, you're able to do the job, then yeah, I'm sure people will give you a chance. Sometimes getting a master's will help by reducing some of your weaknesses. Like for me, it was mathematics. And it helped me understand different areas to where I was able to expand what I was capable of. So if you don't have a master's and maybe you're not quite as skilled and well-rounded as people with the master's, maybe you might be starting off in, I want to say a simpler role, but like a role that is not quite as complex, that maybe you're focusing on the computer science part of things. Maybe you're starting more in testing. But ultimately, like if you've done projects and you're able to explain yourself, you should be able to get in the door. It all just
I see.
depends on who you're competing against.
Yeah, is this true also for roles that require machine learning and AI skills? Or would people with an advanced degree have higher chances? Or no?
Um, I mean, so when it comes to hiring, you go through a couple different levels, right? The first level is the recruiter, and the recruiter doesn't know how to do any of these tasks. They're looking to look through the check marks of, do you have this? Do you have this? Do you have this? And sometimes if you're eliminated by the recruiter because the requirement is you need a master's, you need this skill and this skill and this skill, if you're missing that from the resume, you might just be eliminated, and there's nothing you can do about that. So it might reduce the number of companies that will be options for you. Um, but for those that don't limit that and say it's optional, look at those companies. I would say the level of degree is less important as long as you can show that you have the skills, you've done the projects that are relevant, and you can very intelligently speak through the problems that you've worked through and problems that are very relevant to the company you're interviewing for. If you can show the value that you can bring, then I feel like people should be able and be willing to hire you. Um, yeah. So.
Okay. Yeah, great. Thank you. Yeah, thank you,
Mhm.
Karissa. We went over all the questions and we're running out of time. Last thing, if people need to find you, where can they find you? I know you are on LinkedIn and YouTube, but any other platforms? And what is your goal of like being active on YouTube and LinkedIn?
Yeah, so I'm definitely on LinkedIn, available to connect. I'm on YouTube just based on my name, Karissa Stisser. I've recently started a company called Slamivate, which focuses on robotics education and entertainment. Slamivate, Slamivait, like you're motivated by algorithms like Slam. But I have hopped onto the platforms, but I'm not very active on Instagram and Facebook for Slamavate as well. So feel free to connect with me there. I think my goals for my YouTube channel, I really want to create content that make people fall in love with engineering and help make it easier for people to find their path. So some of my future content is very project based. My son and I love watching YouTube videos like Mark Rober or Stuff Made Here. And so I want to bring that to life with more robotic systems and software so that people can see how they can translate their skills into actually creating projects and eventually maybe turning it into a career.